Progress.
Okay, then I think we're recording. So, hello everyone, I'm George, and today I'm going to be talking about TDD. So, I guess the first question is why? Why TDD? Well, I think to kind of use a slightly pithy phrase that I'm stealing, TDD works because it produces clean code that works. So, this is a quote from a book called Test-Driven Development by Example. And I kind of wanted to start this talk by quoting from this book because this book was written by Kent Beck in, if I can remember my notes, 2002. And it kind of started the TDD movement as we know it. It was basically the progenitor where a lot of the ideas of TDD came from. And I went back and I read this book. And I found that a lot of the ideas behind TDD that he kind of explored in this book have almost been forgotten slightly. You don't hear them as much in modern conversations of TDD, which is kind of what prompted me to come give this talk to kind of try and revitalize some of these ideas, bring them back, because I think a lot of them are really useful. So I guess I'll start with the two commandments of TDD that they outline in this book. Number one, write new code only if an automated test has failed. So this kind of pushes us to the core concept of TDD, which is test-driven development, as this test-first philosophy. So we go and unlike normally where, you write your code and then you're like, oh, shoot, I should really do some tests. And you write those after. TDD is a test-first philosophy. And the second one he outlines is eliminate duplication. So obviously, in some ways, this is just kind of a good tip for writing clean code. But also, I think it goes a bit deeper. And later on in this presentation, you'll see that this actually thought of eliminating duplication we can use in some quite interesting ways in our TDD practice. So let me start at the beginning, where all talks about TDD should start. The red-green refactor loop. So when you decide to do test-driven development, what you're going to do first is write a list of test cases. I guess you could do this on a piece of paper or just mentally, but basically you're going to have a list of behaviors that you want to implement in your system. And once you've got this list of behaviors that you want to implement, then you're going to start on the red step. Red, we write a failing test. So in whatever testing framework you're using, you're going to write a failing test. Here, the little star, because failing also not compiling counts. So either you could be, writing a test for some functionality that's already implemented, but you're kind of wanting a new behavior on that, or you could be, writing a test to test something that you actually haven't written yet. And so it fails because it doesn't compile. So we've written our failing test. Next step, green. This is where we get the test to pass as quickly as possible. And when I mean as quickly as possible, I mean exactly that. I don't care how you do it in this step, just that test goes from being a red cross to a green tick in your IDE. And then we get to my favorite part of TDD and why I think TDD is so powerful. We get to the refactor step. So the refactor step is where we eliminate the duplication, a mess that we've created in our green step. And so when we refactor in TDD, what we do is we take a series of refactoring steps, a series of small or big, we'll go into that later, a series of steps to move our code slowly from this kind of messy state into a state of cleanliness. Each time we do a bit of refactoring, we rerun our tests. We rerun to make sure, is the behavior that I implemented, is it still in there? And when, and then with our tests, they give us the confidence to keep on doing this because we can be sure that we haven't broken anything. And so we can do a lot more of these kind of little refactoring steps. than if you didn't have this test suite, because obviously then you'd have to do it all manually. So, boom, we've got our red-green refactor loop. Let's get into it a bit more. So step one, red, writing the tests, where we specify the behavior. So I've put this in very big text because this is perhaps one of the most important things in this talk. Tests specify behavior and not implementation. Why is this important? Why did I put this in such big text? Well, refactoring is the practice of keeping the code's behavior the same while changing its implementation. And so if we write our tests which go and reach in and touch all of the private variables and private methods, all of the implementation details of our system, then we're going to get a sense that basically whenever we do any of our refactoring, boom, all of our tests are broken, we're crying, everyone's crying, and you never do TDD again. So in a bit more detail, I guess this means tests at the public API of the system under test you are developing. So by public API, I just mean the interface that other consumers of the code will use. So this is generally going to be your public methods. It's really just whatever is kind of the gateway into the code that you have developed by public API. This confused me far more than it probably should have. Public API is not the same as a HTTP API. We're just meaning it in this sense. That's just the entry point. But I've used the term system under test here, which if you are thinking clever thoughts, which of course my brilliant audience you are, you'll be thinking, George, what is this system under test? What should your system under test be? What is this bit of code that we're testing? It could be a class. We could just be testing a single class by itself. We could be testing a module by itself. We could even be testing the whole system. Excellent question. I will get to that later in the talk. So let me get into some other tips for writing tests. One useful tip I find, test isolation. We want to make sure that our tests are separated from each other, because if they aren't, then you're going to get some crazy chains of effects going on with one test affecting another test. So in practice, basically this means that often you're going to be generating objects, the objects you're testing on. You're probably going to want to generate those again for each new test you're running. Often testing frameworks, they have like fixture features, at least in PyTest, which is what I use, that's what it's called. But also this does kind of necessitate the fact that you're going to want your objects to be pretty quick to kind of get off the ground, because otherwise if you're regenerating them for each test, it's going to be pretty slow. Okay, then let me get into some top tips. So this was actually quite interesting little detail from the Kent Beck's book that I thought was quite interesting. So it was never use the same piece of test data to mean two semantically different things, which basically means here I've got a faulty bit of code. I've written an exponentiate function, but actually what I've done is I'm raising the exponent to the power of the base instead of the other way around. And you can see I've written test for it here, assert exponentiate 2, 2. And so the problem here is that I've used two different times to mean two different things. I've used 2 for both the base and the exponent, which means that if I'm debugging this, right, I'm going to be getting really confused as to like which 2 is 2, which 2, is which. And obviously in this kind of play example, it's pretty easy to see what's going wrong here. But in an actual proper bit of code, you might start to get a bit more confused. So generally try and use different bits of test data to mean semantically different things. Second top tip, this is something I think most people have seen. It's the given when then structure. it's called a bunch of different things, but basically all of its different names come down to the same thing, which is when we're writing tests, we generally want to write it in this kind of structure. So given state before the behavior. So we set up the state of the world before whatever behavior we want to run. In here, I've set up the multiplier object. When, boom, we execute the behavior. Ah, fantastic. And then is where we basically check, has it done what we thought it would do? So you can see here in my test multiplier test, I've gone through those 3 steps to check, is the end result, that the result equals 6. Another interesting tip. So when we're writing tests, actually, we're thinking about a lot because we are defining we're doing a lot of different things. We're defining the interface that we want our code to have. We're saying kind of how do we interact with our code? We're defining its behavior, kind of almost creating a little user story in a way. That's a lot of stuff to do. That's a lot of stuff to think. So sometimes let's just narrow our options of what to think about and just start by writing the asserts. So just kind of start with the then step. Think, what is the end case of what I want to happen? And then it becomes way easier to kind of reverse that and to go, oh, I know that in the end of my transfer money test, I want one account to have £5 more and the other one to have 5 less. Well, how do I get to that case? In fact, actually, I was doing this today. It does actually help you kind of focus in what's important. Step 2, green. This was actually perhaps this is maybe my favorite bit of the talk in some ways, because this is something that Kent Beck's book had, which I hadn't quite seen some other ways. Basically, 3 ways he suggested to get to green. One of 3 kind of techniques that we can get our test to pass as quickly as possible. Number 1, fake it. Just return a constant. If our test is expecting, we're expecting emphasize to return hello world in capitals with some exclamation marks at the end. Just return it. Fantastic. We've done our green step. I'm going to reach a bit into the refactor step here, just to kind of show you what you would do from here, because you can see actually with our emphasize function, we've actually got some duplication between the test code and the actual code itself. And so eliminate duplication. That isn't just within the code, it's between the code and the test itself. So you can see I've duplicated the hello world capitalized constant twice. So the way I would kind of refactor this to move to a proper solution is, I would slowly start basically working my way backwards. You see in step 2, I've got a bit less duplication. I've kind of factored something out. And then in step 3, I've come up with an actual solution. I've managed to work my way backwards to there now being no duplication in my code. And you can see how in this series of refactoring steps, where each time the code, that test is still going to pass, we've moved to a proper solution. So first method, fake it. Second method, just do the obvious thing. Everyone here is very clever, and I'm not going to tell you for something really simple that you have to do this kind of faking method. Sometimes when you're familiar with the domain, the simplest thing to do is just to write the code. And this is a pretty big strength, I think, with test-driven development, which is that it allows you to basically change how fast you're going based on your confidence. It allows you to manage the risk in that way. In this example, I've got this add function, and I think I would be pretty embarrassed if I couldn't just write that off the go. So I've just done it right away. Now, if I had actually made a mistake, sometimes the best thing to do is you try and write what you think is the obvious solution. It fails. Sometimes the best thing to do is just revert that code. Start back at base 1. Start back by just kind of faking it and moving in steps till you can get to a correct solution. Sometimes we end up kind of beating our heads against a brick wall of thinking this has got to be super obvious. Sometimes we've just got to take a step back. The third suggestion the book made was triangulation. So triangulation, basically, when we're struggling to generalize some code, when we're struggling to, figure out how to get it to work, sometimes it can help us if we just add some more test cases that can kind of help our brains figure out how we want to do something. Obviously, this is almost a bit of a last resort, something that we don't want to do right away, because here I've been generating kind of duplicate excessive test cases, which eventually I'm probably going to want to delete. But to help you write the code, no problem in just adding a few more test cases. Oh, and a secret fourth method. So this is something in 2002 Ken Beck definitely would have had access to. AI. I don't know, maybe if you want to go crazy, just like let's see, give the AI a crack.
You've been listening to the talk. Well done.
Thank you. I promise there is no more AI in this talk. You can all rest easy. But yeah, maybe just let AI have a go. I don't know how well this works. I'll leave that up to you. So, step 3, the final step, refactoring. So, I'm not going to go into what is clean code and kind of how to change your code to refactor towards that, because how to write clean code is probably something that I could spend many talks on, and everyone kind of has their own opinion. So what I'm going to do here is I'm going to talk about how to kind of get your code to a state in which it fits your personal definition of clean code. So one of the big concepts in TDD is this idea of working in development gears. So when you have written your code, it's green, wonderful. Now what we're going to do is you're going to basically take a series of refactoring steps, a series of steps to move you towards your nice clean code. And so when we're confident in the sphere that we're working in, we can take big steps. Basically, we can go and start making big changes. I might break apart some classes and completely rip out some sections of code, completely reformat it, because I'm confident I know what's going on. But when we enter into areas of more confusion, let's say we're refactoring someone else's code that we've just come across, or we're looking back on our code that we wrote, 2 months ago, then I would say, just drop back a gear. Start by making small changes. And after each of your small changes, just rerun those tests. See if it still works. Then you get super quick feedback of, oh shoot, I've messed something up. No worries, let's revert it. It's that last state. And TDD, it's not going to tell you which quote unquote gear to work in. TDD is just about having the knowledge and making the decision of how fast you're taking it. So that's a quite interesting idea. Another idea in refactoring steps, delete tests not adding value. So what do I mean by this? I mean that we want to delete a test if it fulfills both. It doesn't increase our confidence. So basically it's not kind of covering a different part of our code. It's not lucky into checking a different part of our code, or it doesn't communicate something new. So when we're writing tests, they do test our code, but they are also methods of communication to other developers. And so if our test, even if maybe we kind of have two behaviors, which we think of as separate, but they're implemented by the same bit of code, well, to our other developers, we want to tell them, there are two different behaviors, and maybe those behaviors won't be implemented by the same bit of code forever. So we want to keep those two tests in to kind of lock in, this system should have these behaviors. So that's refactoring. I lied that it was the last step. We're going back to step 0. How do we choose a test to start? How do we choose where to start? Quite simply, we start as simple as possible. Often, I think that developers, when we're writing our tests, there's often the first test we think of as the simplest is actually not the simplest. Often there is a far more trivial case for us to deal with. For example, addition. I've got the +0 case here, right? I just return the first number. Super simple. Why are we starting as simple as possible? Well, basically, it just gives us kind of the first test means that we can use that as an opportunity to build up, the infrastructure, right? The function definition, get that all started. And because if we're jumping in with a more complex case, then we have to write the infrastructure and we're writing the functionality, and it's a bit too much. So just start as trivial as possible. And often that can really help you get somewhere. Here with this paint mixer thing, I'm just mixing the same color of paint with itself. Of course it's going to be the same color. So that's step 0. I lied again. There's another step before this. Should you be using TDD at all? I find that often when you're online, you get a lot of people who get quite frustrated at TDD and its principles. And I often think that is because they are trying to apply TDD to a place which it is completely not applicable. So where is TDD good? TDD is good for when tests provide fast binary feedback. This is a lot of development. For a lot of development, we can write tests which provide fast binary feedback. But for some cases, like creating visual UI, the fast binary feedback is often just looking at it. We just look at the thing and we're like, does this look good? Do I like how it looks? Yes. Obviously, I'm sure I know that you can, there's some test frameworks for UIs. So I guess you could possibly do it. But, for example, if you're using CSS, you're probably not going to want to test drive that. A second case, integration tasks. So often when we're integrating things together, we're dealing with two slow, kind of clunky systems, or two kind of slow systems that are going to be hard to kind of write tests for, to merge them together. So sometimes you might be able to TDD drive integration tasks, but sometimes it's just easier to, work slowly, maybe pair up with someone. And the third one, so I think that some people, especially and this is actually the complaint I think I've seen the most online, is some people, they like to figure out the behavior of their code as they code. Now, this is certainly not me, but I know that especially some people, when they're doing kind of personal projects, where they're kind of using the coding as like an experience to make a prototype and kind of feeling it out as they go. If you're figuring out the behavior before as you code, then TDD is just not going to work, because TDD requires you to specify that behavior up top. And so you're really going to struggle if that's your style of development. So we figured out where not to TDD. And now I enter the controversial section. So this is the last bit of my talk. And this is perhaps the bit that people might shout at me for. This is, we're getting into a place where I'm going to kind of go into some of the debates about using test doubles, about mocking. I might be wrong about everything in this section. I don't think I am, but kind of viewer caution. So, what are test doubles? Let me get into this for anyone who doesn't know. Test doubles are basically techniques to isolate code from dependencies. So we might have our code depend on an object. We have kind of this imaginary object here. And what I'm going to do is, if I don't want my test to depend on that, I'm going to substitute in a test double, some kind of not imaginary, some kind of fake object, which is going to take its place. So that then we're not depending on that object anymore. We've isolated the code under test, our system under test, from that dependency by swapping it out. There's a couple of different types of test doubles, and this is where I would have really appreciated having my notes. So I'm just going to do this off the dome. So first type is we got dummies. Dummies, if I remember correctly, are basically if you need to submit a test double for something that it's basically just there to fill out a parameter list. So your code, your test isn't actually the code isn't actually gonna use that dependency, but it just requires it to be there. You can just pass in a dummy. It doesn't have anything, it's not gonna do anything, but it's just there to fill out the parameter list. We've got a fake. Fakes are basically a fake implementation of whatever dependency you have. So the classic example is a database. So let's say we have a database, and a fake might be that we might use an in-memory database implementation to test with. So obviously, in actual production, right, the way that we faked this object isn't going to be suitable, but we can kind of substitute an unusable version as a fake. If this is a little bit hard to visualize, don't worry, I've got some examples coming up. Stub just returns constants. Oh, that's a bit simpler. A spy is kind of like one of the previous ones, but it also collects information on how it's called by whatever it's called. So, it might have a counter of like, oh, this method was called this many times. And then a mock, perhaps the most controversial of all test doubles. Mocks are test doubles where basically in the test, you're going to pre-program them to say, you expect to be called. This method should be called this many times. You should receive this input, and you will return this, and it will basically specify in the test how this dependency is going to be used by your code. I should have actually, before I got into this, I should have specified in this kind of talk of test doubles, some of the terminology when you go online can be a bit all over the place. Some people might call all of these mocks. Some I've seen terminology going wild. I've just used the terminology from this article by Martin Fowler because it made the most sense to me. So just an example of some code that I'm testing here. This is some payment gateway. Yeah, it's just for some kind of financial transaction. And I want to switch out the payment gateway for some kind of test double because I don't actually want to use the payment gateway I want to isolate my code from the payment gateway because it's kind of thorny. It will be hard to test this. Another example probably would be your database. You're probably also going to have to test double out. Or like if you're calling external HTTP APIs, you're also going to want to test double them out. So testing with a stub. So you can see here, I've written this stub payment gateway. It's literally the payment gateway, but I'm just returning a constant each time. So whenever it says charged, just returns charged successfully. Sometimes this is all you need. So that's a stub. A fake, you can see here, I've written a fake. So here we've got, I've written basically a fake charge function, which can kind of approximate what the actual payment gateway might do. But in the end, you wouldn't want to be using this. And I can kind of slot it in instead of the actual payment gateway to use in my tests. Pretty simple. Yeah, so in fact, when I we test database functionality, I've ended up, one of my favorite libraries is called MongoMock, which basically creates this fake MongoDB, an in-memory kind of MongoDB instance that you can go and you can shoot requests at. Super useful. And the mock, the controversial mock. You can see here, I'm going and I'm asserting how many times charge is being called. I'm kind of specifying the return value. In this case, I've used the unit test mock library for Python, but I know that various languages will have different kind of implementations of this. So we've gone through what those different test doubles are. So how should we use our test doubles? Well, and this is where it gets controversial, guys. Everyone strap in. We're talking about classicists versus mockists. So classicists, these kind of people who are of the mindset that we should use real objects whenever possible. We only want to use test doubles when we encounter a thorny dependency, like the database that I was talking about, when things are too tricky or will be too slow to actually call in our tests. Pros of this, our tests don't specify implementation details. When we're using the real objects, then you know, we don't have to write test doubles that accidentally specify implementation details. We could just leave it up to the real objects. It's wonderful. The cons, sometimes if you're using real objects, then you have to really set them up. That can be complicated some of the times. A different approach, mockists, and this is kind of an approach, I think it's called the London School of test-driven development. So mockists say we should always use mocks for any objects with interesting behavior. So for basically for anything that isn't trivial, we should instead use a mock for that. And so in that way, we're kind of specifying almost, as well as specifying in our test, the inwards interface of what our code should do. With the mocks, we're also specifying the outwards interface. So basically, how should this code call its dependencies? Pros, what's good about this? Our bugs and dependencies, they don't affect tests because we've basically isolated, by mocking everything out, we've isolated our code, our test code, so that it's just that one class. So if, you know, a test goes red, you know exactly where it's going to be. Cons, if we ever change how two different classes interact, then we're basically going to require all of our tests to change. And so simply, when you're writing code, you'll probably end up just not changing how classes interact. So I'm going to tip my hand a bit here. I think that the classicist style of writing tests seems far more intuitive and simple to do, because I quite dislike going back and changing my tests once I've written them. And so it means that I just don't refactor code. But if you're a classicist, there's even more controversy. We're not through the controversy yet, guys. What should your system under test be? Basically, when we're testing our code, our system under test, whatever we're testing, that bit of code, it could be, if we're going large, we could test our whole system at once. Or some people say, maybe actually you don't want to be testing your whole system at once. Maybe you want to test just a little bit of it. Maybe you just want to test like a few objects together. So how big should our system under test be? Basically, before we start kind of isolating that bit of code by using test doubles to make sure that we can kind of isolate those objects together. So if we have a large system under test, so we're basically doing no isolation of bits of code with test doubles from each other. Problems. If you have a big system that has a lot of objects which might be complex to set up, your tests are going to be slow. And if your tests are slow, you're not going to run your tests. The refactoring part of the cycle falls apart. Secondly, coverage could be low. If you're kind of testing all the way up here and like you're trying to get to so if you're testing at like the interface of your system under test that's all the way up here, and you're actually trying to test some kind of error handling case all the way down right at the bottom of your code, that can be really hard to get to. It can require like a lot of, fixture wrangling. And so coverage, it can be hard to cover everything. And also your tests become sensitive to faults in part of the system's not being tested, which means that it can be quite hard when a test goes red. You can be like, oh, where did this error come from? Oh, just anywhere in your code. Just anywhere in your code, guys. Should be pretty easy to find. So that's the problem with a large system under test. Okay, sure, you've convinced me. Let's go smaller. Let's maybe isolate a few maybe only a few objects together. Maybe using test doubles, we could decide what type of test double makes sense for the case. There's still problems. So test double setup, that's going to become more complex. And the problem, similar to Mockist TDD, is that our test double implementations become coupled to our implementation details. Because basically, whenever you isolate two bits of code from each other to kind of help you make a smaller system under test, you can't change how these system under tests interact without changing their tests, because you kind of have to define in those test doubles how they're going to interact. Which means that while TDD gives you a lot of power to refactor within that system under test, you've got a bunch of these kind of system under test and they stay rigid. So we've got two ends, problems between both. What's the right answer? Probably changes between projects, but I found this, and this felt satisfying to me. So it said, Robert Martin said, use test doubles across significant architectural boundaries, but not within these boundaries. So basically what this means is, in Python terminology, we're going to test each of the modules in isolation from each other. So here, the module here in Python, that's just what we call kind of one of these architectural zones of concern. Other languages might call it other things. I know you guys are the experts on those languages, so I'll leave that up to you. But basically, here I can isolate with test doubles, so you can see with the arrows, let's say those are the dependencies, and I can just slide in some test doubles there to isolate those from each other, so that I don't have to worry about having a huge system under test. I can kind of isolate them from each other, deal with something that's a bit more manageable, but still has that advantage of not having, only a few objects under test. And hopefully those kind of architectural boundaries, they will have slightly more constant, slightly more, you're building on slightly more surer ground when you're kind of hoping that the interfaces between those are going to stay a bit more constant. Although you're still going to probably have to change the interfaces between those. That is going to be a pain. And I'm not sure how you get around that. So that's been my talk. Thank you everyone for listening. What time? How long did that take us?
5 minutes exactly.
40 minutes exactly. Oh, fantastic. So yeah, thank you everyone for listening. I guess we can do questions if anyone has any questions. But also if you don't, that's cool with me too. Thank you everyone. You've been a lovely audience. And if you do end up having thoughts, I would be curious if people have other opinions about this, because this is something which I've kind of constantly been trying to learn about. It's been a bit of an obsession of mine in the last 6 months. So wonderful. Okay then, let me end the recording.